Right, what we'll do now is we'll introduce the second of the big ideas in the mechanics, the actual idea of working with forces. Now at GCSE, you would already have introduced forces. You'll have talked about different types of force. You might talk about friction, you might talk tension, you might talk drag and things. We're going to look at the names of forces a bit later. So first of all, we're going to introduce just two of Newton's three laws of motion, and we'll introduce the third one later on. And in the second lesson this week, we'll look at combining forces to get a resultant force. Okay. So this first lesson introduces Newton's first and second laws. Newton's first law, I can't remember if it's part of GCSE physics or not, but Newton's first law says that an object continues to move with a constant velocity or remains at rest unless acted on by a force, or there's no acceleration if there's no resultant force. Okay, we talk about that that state being equilibrium. Newton's second law says that a resultant force creates an acceleration of A when applied to a mass m. Now, if you look carefully at that, in the written part of this, you've got F in bold, you've got A in bold, so A and F in bold, but M not in bold. That's because force and acceleration are vectors and mass isn't. So in this bit here, we should not have had mass in bold. I'll work through the examples in the book. Okay, this is the first example, so you can read that. So part A, Newton's second law says force is equal to mass times acceleration. State that. Notice that they describe something in tons, which is that in kilograms, because we've got to be working in kilograms, meters and seconds to get this answer if you substitute mass and acceleration into that formula. In part B, a constant speed in a straight line, and it does say straight line, constant speed in a straight line would imply constant velocity, which implies the acceleration is zero. That state is called equilibrium, and so F is zero. It'd be important to say that's the resultant force, but if we're ignoring friction, that's also the driving force. So the F in F equals ma is a resultant force. Right, the next example, because we can be working in 1 or 2 dimensions, but we're going to, in the year 12 work, we restrict ourselves to working in either forces which are parallel or perpendicular. We don't consider forces acting at an angle like that to each other. But in 2 dimensions, we can use the vector notation, 14 in the x direction minus 21 in the y direction, vector acceleration, magnitude of the acceleration. F equals ma, as we're working with vectors, I've underlined the vector parts of it. We can put that in vector form instead of the F, and we can still find the A. I've turned 3.5 to 7 over 2, so I can swap it over. Now, could we notice importantly here that the 7 over 2 is a fraction? Right, it is a fraction. 14 and minus 21 is a vector, because that tends to be what people confuse, is where you put the line for fractions or not. So we've got a column vector and a fraction in the same thing. 2/7 of 14 is 4, and then 2/7 of minus 21 is minus 6. Now that's the answer to A. That's the acceleration in vector form. Magnitude means size, it means length. we apply Pythagoras to the two components. Okay? On the exam, make sure you, even though it doesn't matter whether you put it in as -6 or 6, state it as -6 there and then get the correct answer. Just be warned though, if you don't put the brackets on your calculator, you get the wrong answer. Okay, that's the magnitude of the acceleration. So we've got the acceleration. If they just ask for acceleration, the vector form. If they want the magnitude, Pythagoras applied to it. Next example, a ball with that mass has that speed. It slows down because of that force. How far does it travel before coming to rest? So nicely, what we're going to do here, we're going to link the Newton's laws to the SUVAT work we've already done. Okay, so we've got the mass, speed, and the force. First of all, we use F equals ma to get the acceleration, and then we've got some quantities for SUVAT. Now notice here, we've got to consider the fact that it's a force which is slowing it down, so that's negative. The acceleration is negative. We then end up with u is that, so the initial velocity is 3.6, the final velocity is 0, came to rest. We know the acceleration. Quote the right SUVAT rule, work it through carefully. Okay, nice link between the kinematics we've done and the Newton's laws we've just introduced. Right, exercise 11a has 11 questions which make good use of Newton's first two laws. Good mix of 1- and 2-dimensional problems. The 2-dimensional problems use the vector notation, whether it's the column vectors or the IJ notation. That should have come up at the end. The first of this week's lessons and your homework time, but homework's a funny concept, isn't it, when you're at home all the time? Work your way through 11a, so you've tried each type of question. Particularly make sure you've done the questions which combine Newton's second law and the kinematics we've just been studying. Constant force implies constant acceleration, implies SUVAT. We can look in the future about what a non-constant force would imply. Summarise the ideas in your notes, but I mean, make sure you've written down Newton's first two laws. Send me your answers to 9, 10 or 11, whether you do that on the first lesson or whether you wait for the second lesson. Good luck with that, and as always, you can email questions and we can do worked answers either on YouTube or in Edmodo.